Hi everyone, I'm Haidong Zhu from University of Southern California. Today I'm presenting our paper, Utilizing Every Image Object for Semi-supervised Phrase Grounding. We first present the definitions of the phrase grounding tasks. Given an image and a language query, the phrase grounding task is to localize the object described by the specific query in this image. For example, in the first image, we use a red bounding box to point out the black car based on the given query. Phrase grounding systems are usually trained in a supervised mode where every object in the image is annotated with a discriminative phrase, but such annotations are laborious and expensive. Missing annotation can actually cause the methods to infer incorrect negative examples. Our work is to aim at utilizing all objects in the image, even those that are not annotated. For example, in the figure 1, a car is annotated as a black car, but the other car is not. A detector can find out a bounding box for this car with its category names, but just the category names at the query is not sufficient to improve the training of the grounding system. We present two examples here. In the first image, suppose we have the annotation of the black car and we only have the category names for the red one. If we use the category name car as a full query, the system will treat the black car as a negative example for the query car, which is incorrect. In the second example, suppose we have the annotation for the white dog lying on the grass on the left as the query. When we see the brown dog as a negative example for this query, we cannot distinguish which part of the query is not correct: white, dog, lying on the grass, or on the left. We propose two embedding predictors named LSEP based on the MATNet model to deal with the incomplete queries. We show the architecture of MATNet first. MATNet is a grounding system built for the supervised phrase grounding setting. It automatically splits the query into three parts: subject, relation, and location. In the same time, it also extracts the corresponding visual feature embeddings for the three parts. Then it calculates the similarity between each pair for each part and sums them up with the weight generated from the BioSTM network. Based on the MATNet network, we add two additional modules: a subject embedding predictor, which predicts the category name and attributes from the visual features of the object, and a location embedding predictor to generate the language embeddings for the locations. When language queries are available for some specific object, we directly use the BioSTM to generate the language embeddings. When the queries are not available, we first generate the language embeddings from the detection result with two embedding predictors, and then we train our grounding model based on the generated language embeddings. We first show some visualization results here. Results on the left are from MATNet, while those on the right are from LSEP. We can see that while MATNet can find the object that belongs to the same category as the object described in the query, such as in the first example, MATNet can localize a donut, but it's not the donut that we want in the query, while our model can find the correct instance of that category. We then show some numeric results here for the semi-supervised settings we described before. We present four settings whose details can be found in our paper. They are the annotation-based selection, image-based selection, category-based selection, and supercategory-based selection. We show that when some objects are given with incomplete queries, and we can find some other images containing the full queries for the same object category, the performance of the grounding accuracy improves when we apply LSEP to train on these images. When the objects without full queries are novel categories, such as those described in the supercategory-based selection settings, the accuracy for the grounding does not have significantly improvement, but F1 score indicates that the network successfully transferred the attributes from the known category to the unknown one. This is all for my presentation today. Thank you so much for listening.